Okay, let's start here. Let me start with person because some of you still, I think, have not signed up to person. If you have not signed up to person, go back to the first week lecture where we explained how to sign up and follow the steps and sign up. Again, you need to follow the instructions here. I will repeat that because I noticed some of you still have not signed up. So download this PDF, go to Brightwave. If you go to the Brightwave, it will show you the class material and copy that access code and then go to access person. Anytime you want to access to the material, don't use, I will remove this. Use access person, okay? Don't use this or this. Use access person, or I put all the links here. For example, homework one, you click on homework one, it will take you directly to the homework. I will click access person. It will take me to the website. Yeah, we have 4 students. They have not signed up. We're supposed to have 40. We have 36. Okay. Again, if you have not signed up, follow the instructions and sign up. There's no time. I extended the deadlines. Oh, this should be tomorrow. I extended the deadlines, so let's change this also to tomorrow. I don't know why it is today, so I will change it to tomorrow. Okay, so this is tomorrow. Homework one tomorrow. Chapter 1 quiz. What is your name? Tiron. If you don't mind, I can show the names, If nobody minds, I can show the names on the grade book. Let me see. What do I have here? Who signed up? Yeah, that's what I have. I think you are here. Yeah, everybody who signed up should appear here. If you don't see your name, that means yeah, it says 36 students, so we are missing 4 or 6 maybe.
And where did you say that the access code is?
Okay. Yeah, the access code is, do you have computer now in front of you?
Yes.
Okay.
Yes.
Can you go to the class website, this page? Are you there?
Yes.
Okay, click on any module. You
Okay.
see
Okay.
this? You see this
Yeah.
course resources? Yeah, click on
Yeah.
it. You see the PDF?
Mhm.
Open the PDF, go to Brightwave.
Okay.
If you don't have account, log in with your CAU or change password. And then let me do it. Let me see. I don't want to mess with my. See, it will show you something like this.
Okay. Okay. And then just log in.
Yeah, log in. Yeah, you will see I have different accounts, so you will see one of these. If you click, let's say this is your account. You see my screen. Copy the code. Do you see
Okay,
that?
okay.
Yeah,
Yeah, yeah,
after,
yeah.
yeah, after you do that, go to access person here. You see the left here. Select
Um,
access person. Access person,
okay, okay.
open person, and then select I have code. Okay? And just put the code and you should be okay. Okay?
All right, thank you. I'm doing it right now.
Yeah,
I'm
make
trying to
sure you
find
do
the
it.
access persons on it.
Yeah. Okay. Any questions before we start about person, about the assignments? So, and I don't know why some of you they don't see the calendar. I put the calendar and it is showing all the assignments. It's showing everything, you see? That's what you should see. I don't know why some of you they don't see. I don't know what's this. You should see all the assignments. You know, these were like before, so I changed them. This, there is a quiz. You know, you should have done all these before. That's why if you did not do them, they are due all tomorrow. I keep pushing them until, you know, they are all on the same day. But there is a quiz for chapter one. This is chapter six homework from person. And I think I will change. We will wait for this. If we finish what is required before this date, it will be the same. This is uh, Canvas assignment. Yeah. So if we don't, so we will push it a few days. Okay. So what we did last time, we started covering the 7 tools of quality. We talked about the check sheet. We talked about the flow chart, uh, scatter plot, and now we have the Pareto chart. So the Pareto chart is a graph to identify a plots and plot problems or defects. So if you have a problem you need to solve or you need to solve, let's say, and you don't know, you have different problems. You don't know how to start, where to start, with which problem to start, which problem is the most important problem. So the first step is to create a Pareto chart. Then, based on the Pareto chart, you start with solving. For example, we have problems A, B, C, D, E. These problems could be like customer complaints, defective parts, any problems inside your service or manufacturing facility. So here, based on this chart, I should concentrate on problem A. Okay. So I take problem A and start analyzing the data using other tools, and then solve problem A, then move to B, move to C, D, and E. Let's see an example here. We have paint nonconformities for 1 month period of riding lawnmower manufacturing. So they have problems with the paint. These are the problems. So they want to know which problem is the most important problem, how much the weight for each problem, where do we start? So to do so, I take the data to Excel. Let me see here what I have. Of course, every time I cover something, you should have the Excel sheet on the class website. So let me remove this. So here's the data. To create the Pareto chart, I highlight, select the data I need to. I go to insert, and then you see I select Pareto chart. So Excel will build the Pareto chart for me. See, this is our Pareto chart here. So look at the Pareto chart here. Uh, you see the light spray is the most important category here. It is the light spray. It is very important. So I start with the light, solving the light spray problem. I go, for example, take, oh, what caused the light spray? I build like a fishbone diagram. I say, oh, the paint, maybe the painter, tools, environment. Uh, I list all the possible uh, reasons, and then I take the paint and break it down and check, inspect the paint. If it is okay, it is okay. Then I take the second one. Then we solve this problem. Okay. After we solve this, we start with the second one. Okay. That's the Pareto chart. Any questions? Questions? No questions?
No, sir.
Oh, the other tool is flowchart. You know, flowchart, you should be familiar with flowchart. It's a chart that describes the steps in a process. So if you go, for example, if you take any process, applying to the school. So first step is to go to the class website, to the school website, fill the application, pay the fees, for example. This is a process, any process. It should have a flow chart. To understand the process and the steps in the process, you need to start with the flow chart. Okay. This is an example for flow chart for repairing defective unit from a customer. For example, we receive, accept the defective, troubleshoot, locate the problem, and you have a decision. So of course, for flowchart, there are specific shapes you need to use. I want you to understand what's the process chart, the flowchart it is one of the tools of total quality management. When we use it, why we use it, I'm not going to ask you to build a flowchart, but in the future, if you will to build a flowchart, or if uh, you should know that this is the flow chart. Observe the process, the steps of the process. Okay. Histogram. Histogram is a distribution. You see, this is a distribution. Call this a distribution. Shows a frequency of occurrences. So this is a frequency here. This is the frequency. So these are numbers. Okay. So the highest frequency here for this one. Okay. This is, for example, this histogram is uniform, is bell shaped. Okay, symmetric. For this example, not all the histograms should be the same. Okay, so let's understand it more. In the last 70 games, a professional basketball player made the following scores. They made the following scores. Okay, so use this data, construct a histogram. So when you look at this data, you say, oh, okay, they made 10, 7, but you don't understand the data, what's going on. So to understand the data better, to explain it, if we build a histogram, so we can uh, interpret our data. So what I do, I take this data to Excel here. By the way, let me go back to the class website. We are here. You see, you will find everything you need. Scatter plot, there is a video, how to build a histogram in Excel, and there is a PDF also step by step, and this is the data. Okay, so everything we cover is in here. If you miss something, you will find it here. Okay, let's go back to the histogram. Let me remove this histogram. So first, I put the data here. It's very easy. Select the data, put it in one column, and then I go to insert and put my histogram. There is a histogram now. We can tell, oh, of course, I need to add titles. So I say, oh, this is the score, this is the frequency. Okay, that's very important to add the titles to know what is, this is frequency. If you have a question, ask me. This is the game. This is, for example, here. And this is uh, basketball game histogram, for example. Okay? And then there is something, these are called bins. So from 6 to 8.1, I want to make it better. So what should I do? We added the titles, we added everything. I click on this, for example. Sometimes it doesn't work, I don't know. Format, I don't want to format the chart area. I want to format the axis. Okay, let me try again. I need to hit this and right click. See, now it's working. Okay, I need the bin width to be, for example, 2. I can change it to 2. It will be changed. It looks better now. For me, it looks better. So now let's look at this histogram. This histogram here. 14 to 16, we have 29. So we have 29 here. It stopped working for some reason. The pin. Anyway. So we have 29 here. Okay. So what is the percentage, let's say, of the scores between 14 and 16? The percentage for the scores between 14 and 16 is equal to 29 divided by 70, which means 41%. Okay? What is the percentage for the scores between 6 and 8? It is equal to how many between 6 and 8 divided by the total, which is 70. It is 0.028, for example. Okay, this is our histogram. It's the same. Any questions?
No.
Oh, the other tool, which is very important, which will we spend later in the second part, sometime on it, is statistical process control chart. It is a chart with a time on the horizontal axis to plot value of a statistics. So we have upper control limit, lower control limit, and target value. So you collect, let me remove this stuff. Yeah, you collect data for any process. It could be for waiting time in a bank, in a hospital, in a restaurant, or it could be for manufacturing, like dimensions for a specific piece of product. After you collect the data, you plot these are averages. These are averages. These are averages. And then we plot the averages here are dots. And then we do some calculations. And then we plot the upper and lower control limit and the target value. And then we say, oh, this process is in control or out of control. It looks like this process is out of control because we have this out of control points. So this will help us to control the process and see, oh, okay, what caused this point to be out of control? We go back, do investigation, and find out why this is out of control and solve the problem. It could be a problem. Like let's say these are waiting times for customers. So we find that between probably 1 and 2, this group of customers waited like 2 hours, which is too long. Oh, we find out, oh, what caused this waiting time to be long? Oh, maybe we find, oh, the computer was down, for example. Oh, we want to make sure that the computer is always working and we have the maintenance guy and something like this, Use statistics and control chart to tell when take corrective, as I mentioned, drives process improvement, measure the process. As I just mentioned, if you need to measure the process first, you need data. You need data. Without data, you cannot control the process and eliminate the cause or solve the problem. This is another one. It's similar. Upper control limit. This is above. So this process is out of control. Also, we'll talk about inspection later. Involves examining items to see if item is good or defective. Inspection, quality control. So every time we make products, so we do inspection. We need to find out before we deliver the product to the customers. We need to know if our products meet the customer expectation, meet the specifications, for example. We inspect them. To detect defective products does not correct deficiencies in the process or product. Inspection is not correction. it is inspection, exploring, check the parts if it is correct or no, if it is bad or good, okay? And it is expensive. So there are like some issues. The inspection is expensive because if you want to inspect every single part leaving the facility, that's too expensive. So there are some techniques we can use to do that. When and where to inspect, you can inspect after you make the product, before it is delivered. Of course, it should be inspected before you deliver it to the customer. And for service after the service is completed. Okay. And this is how Samsung example phones are tested. Different techniques are used by different businesses. Of course, as we said, there is variability sometimes, errors, cannot inspect quality into product. Okay. There are like different techniques uh, can be used for inspection. We call this, I think we will cover it later in the next part, sampling. You take samples, okay? Oh, there's something called Pokiyoki, is the concept of a foolproof device or techniques designed to pass only acceptable products. They call this like if you make products with a specific dimension, if they are bigger or larger than that dimension, that measurement didn't go. Okay, for example. Okay. This is for airlines, for example, they are interested in the service quality, what to expect, for example, lost airplane door open, lost bag, or different reviews. It depends. Uh, Attributes versus variables, that's very important. Let's start with variables. Variables measure dimensions such as weight, speed. It's something measurable. We call it variable. If we can measure it, okay? If you can, if it has weight or length or width, this is a variable. But if you are, for example, painting, it could be good or bad, acceptable or not acceptable. You cannot measure it. Okay. So this is called attribute, something you cannot measure, good or bad. And we talked about the service quality, total quality management in service. Of course, it's more difficult to measure the quality in service because it's hard. It's not, it's in goods. You make products, so you measure the quality of the product, but in service, it's not easy to measure that because you don't have actual product. So actually, you need to send, for example, a survey for the customers, ask them about the service. And did it meet your expectation or no? You know, this is an example for airlines. They measure the time, how long it takes you to leave the airplane, it depends. So it's hard. Determinants. This is a table 6.6. Determinants of service quality. Reliability, access, communication. Reliability. When we say reliability, we mean like performance. Actually, reliability is defined as quality over time. Okay, that's what's reliability in quality. So These are the determinants of service quality. Depend on these credibility, communication. Tangibles include the physical evidence of the service, understanding, knowing the customers was making the effort to understand the customer needs. Do they understand the customer need? Concern with willingness or needs to employee to provide service. Reliability, access involves approachability and ease of contact. Okay. Managers should have a plan when service failed. Of course, when service failed, you should have a plan like Marriott's layer routine. Listen, apologize, react, modify. The service quality technique, direct comparison between customer service and expectation. When you receive a service, before you go receive this service, you have some kind of expectations. So after you receive the service, you receive the actual service. They need to know, did we meet your expectations? No? Yes? Did we exceed the expectations? So we finished the first part of chapter 6. Make sure you do all the assignments related to this part. So let me change this. So we are in week 3. So let's say week 3 here. Oh, here we'll go over week 4. What we have all this stuff. I will activate this. We'll show this. Let's leave this. Okay. So any questions before we move to the second part? Yeah, in the second part of chapter 6, we will talk about one of the tools of total quality management, which is statistical process control. We call it SPC. SPC. We will also talk about process capability and sampling. So it's very important. If we have a process, we need to know if our process is in control. What does that mean? Do we make good parts meet the customer expectation and the specification of the original design or no? So of course we are making parts, but we need to know if we are making good parts, we can sell them. Our customer will buy them because they meet the expectations and the specification. That's what we are going to do. When you complete this supplement, you should be able to explain the purpose of the control charts, the role of the central limit theorem. I removed this probably. This can be covered in statistics. Build X bar and R charts. That's what we are going. So we are learning only, again, just these two. You will find in the textbook too many charts. We just covering these two charts. There are like X bar and S chart, P chart, PN chart, MP chart, moving average chart. I'm only covering one type of charts, only one. Okay, so we're going to cover X bar and R chart. We are going to calculate the capability and then talk about something about sampling. Okay, that's what we are going to cover in this part. We are not covering everything. Okay, there are like many charts. As I said, we cover some of them. One chart only. Of course, As I said, if you are interested in learning, you can read this, but we're not going to cover this. We will learn how to calculate the CP and CPK. We will talk about acceptance sampling. Okay. The objective of a process control system is to provide statistical signal when assignable causes of variation are present. Okay. When they are assignable means a reason behind it. Assignable cause. When something we know cause this variation uh, to occur. Okay. Variability is in every process. It could be assignable causes. It could be natural causes or common causes. Okay. Provide statistical signal when assignable causes are present. Quick ins appropriate action to eliminate assignable causes. Also called common causes. Natural, we cannot control them. So variation, when we say variation, our goal when we study quality is to remove variation. Variation is not good. Variation, that means we have different dimensions, different measurements. If we are making parts, we need all the parts to be around the average, that the target, let's say. If we take a quiz, we need all the students to score around the target. But if you have somebody receive 20, for example, that's not good. And you have somebody received 100. There is variation, a big gap. That's variation. We always work on reducing the variation or variability. If the distribution output falls within acceptable limits, the process is said to be in control. The special causes like our machines, people, environment, material. So our goal is to eliminate the bad causes. Okay. Let's a little bit talk about like samples to measure the process. We said, let me make this easy, just summarize the sampling. Uh, let's say we have facility, we make parts. We make like 20,000 parts every day. Okay, I will summarize the next few slides here. Let's say we make 20,000 parts every day. So we cannot inspect every single, let's say we make pencils. Okay, we make pencils and we cannot inspect every single pencil every day. So what we do, we use what called sampling. Let's say we have shifts, different lines. We take a sample. Let's say we have this line. We have 100 or 10,000 pencils we make here. So we take a sample and take this sample, inspect it. If it passes, the whole lot will pass. If it fails, the whole lot will be failed. Okay, and there are like different techniques in sampling. They call it sampling plan. Okay, we are not going deep in that, but that's how it works. Okay. After samples are taken from stable process, they form pattern called distribution. This is called distribution. Shape for the distribution. So for example, the only natural cause of variation are present the output of process forms distribution that's stable over time. This is stable, you see. If we see something shifted to left, right, up, down, so there's something wrong with our process. See here, if assignable causes are present, the process output is not stable over time, and it's not. This is not stable. Look, it goes up, down, so there's something wrong. Okay. I will stop here and we will learn how to build control charts later. Okay. As I said, there are like many slides here, but what we will do, we will learn how they are just describing how to build uh, the control X bar and R chart. So I put lots of examples here for you. Okay. Example in PDF, example of X bar chart in PDF. I should have recording. Yeah, here, recording here, how to build these charts. Okay. Maybe next week I will post because the first exam, after we finish this part and take the quiz for chapter 6, we will start thinking about the first exam. The first test will cover chapter 1 only and chapter 6, okay? So I will post the practice exam later next week. But after we finish the quiz for chapter 6, there is a quiz. So next week, probably I will post this assignment. We are not ready to take this assignment yet. This assignment is about calculating the control limits at CP and CPK. We have not finished this yet, but we will do this next week. And make sure you finish all these assignments. And if you have questions, let me know, okay? Any questions?
No, thank you.
Okay, thank you. Let me see.
And I had tried to I had still tried to do my book, but it told me to contact support so they can so they can log me in. It said that the access code like wasn't working on my end.
Oh, the access code is not working?
No, you want me to text you like the screenshot I had got.
Yeah, yeah. Let me see. Yes,
All right,
email it to me. Email it to me.
all right. I'm about to right now.
What do you see? Did you copy? Do you have the code from Brightwave?
Yeah. And
And
they
went
said
to access person and it says the access code is not working?
It said
yeah,
already been used. Like the code
no,
has
It's
already
already
been
mine
been
said
used.
used. Oh, maybe something wrong. You contact them because you already paid for this code. They should provide you with another code. You already paid.
yeah.
Don't pay. Yeah. Talk
It
to
say
them
but
or
it
go to
say
the.
incomplete course linking.
It says
You
what?
heard me? It say incomplete course linking, and then it say contact your instructor and provide them with the text of this message.
Oh, can you send it to me?
Yeah. I'm finna email it to you right now.
Yeah, email it to me and let me know if it works. That's weird. We have like 36 students already got their codes. I don't know why you don't have it for some reason. I don't know. But contact them. And if there is something I can do, definitely I will do. But
Okay, yes sir. Thank you.
yeah. And after you get the code and everything works, let me know so I can open the assignments for you again.
Yes sir. Thank you.
Oh,
I'm emailing them to you right now, so you'll be able to check them. My name
yeah, I
Marcus
just
James.
want to see what's wrong because that's weird. But they should provide you, you need to call them or call the office, the bookstore to provide you with another code. I don't know what's wrong. Did you use CAU email?
Yeah,
account?
yeah. I had using my student email.
Yeah, something wrong. Okay, but also I just want to take a look and see why this what's happening. But you also need to contact the customer support and the bookstore and tell them, look, I have the code, but it's not working. You need to bring me another code. They will give you another code. They should.
Yes, sir.
Okay,
Yes, sir. Yes, sir. Thank you.
thank you.
Sir, are you going to be in your office later on today?
I am virtually available today, so if you need something, you can stay after the meeting and ask me. I have virtual office hours
Okay.
soon. Yeah, you can stay. You stay. You don't leave the meeting, okay?
Yes,
Hello?
sir.
Oh,
Yes,
okay.
sir. I'm going to
Yeah,
stay.
yeah, yeah. Okay, let me end the recording. It's